Hey, today we are going to solve and graph linear inequalities. So, some things that we need to get out of the way first is some vocabulary. A mathematical statement with an equal sign is called an equation. So, if it has an equal sign, please remember equal. The EQUA is the same thing as equation in the beginning, so that's a way you can remember equal signs go with equations. However, a mathematical statement with one of the following signs is called an inequality. So if you have a sign that looks like this, where if you make an L with your hand, here's my L, you see it? If I make an L and I take this top part and I move it this way slightly, it looks like this now instead of this. Okay, so that is a less than symbol. So L for less than. That's going to look like this. Now, if we want if a less than symbol and an equal sign get married and they have a baby, that sign would be called less than or equal to. It's going to have properties of both the equal sign and the less sign. So to make a true statement, the numbers could be less than it or it could be equal to it. Obviously, you can't have both less than and equal to a number, but it could be one or the other. The next symbol is a greater than symbol. Notice this one does not make an L. It's backwards, so that's why it's not a less than symbol. And then last but not least, if a greater than symbol and an equal sign get married, have a baby, their baby would be greater than or equal to. Again, just like the less than or equal to, it's going to have the properties of both. So some examples of inequalities. If I look at example number 1, x is greater than 2. What that means is that all the numbers, all the possible solutions must be greater than 2. So that means it's going to include all the numbers bigger than 2. So that's going to be an open circle, and we're going to talk about open and closed circles in a second, but this will be an open circle on 2. And then it's going to shade all the numbers that's bigger than 2. So that means I'm going to shade going this way. And don't forget, you must shade in your arrow as well to show that it keeps going on forever and ever. So the next example is example 2, x is less than or equal to negative 3. Now what that means is that x can be any number that's less than 3, but it also can include the 3. So it includes all numbers less than 3 and negative 3. So this time, since it's including it, it's going to be a closed circle on that number, which was negative 3. And then you're going to shade in, because remember, shading is all of the solutions, all the numbers that's smaller than negative 3. So I'm going to go this way to the left, and then I'm going to shade in that arrow to show that it keeps going on forever and ever in that direction. So something to remember, if it's a less than or a greater than symbol, you will have an open circle. The reason why you have an open circle is because it does not contain that number. Whereas if you have a less than or equal to or greater than or equal to, it will be a closed circle because it does include that number. That circle is shaded in. So remember, the shading is all those solutions. So you're going to solve an equation with one variable almost the exact same way as you will solve an inequality with one variable. And I'll show you the equation first, since that's what we're used to. Our goal is to get this x by itself, but attached to the hip of the x is the 6. That means we've got to get rid of everything else that's not in that box. So I got to get rid of this minus 4. To get rid of the minus 4, I'm adding 4 to both sides. Negative 4 plus 4 is 0, so I'm left with everything in that box. 6x is equal to 30. Now my goal, again, was to get this x by itself, so I've got to get rid of what's attached to it, which was the 6. To get rid of the 6, since it's being multiplied, I need to divide by 6 on both sides. That gives me the answer, because that's 1x, is equal to 5. Now to solve the inequality, you're going to do the same thing. Draw the sign down the inequality symbol. And then you're going to identify what you're trying to get by itself. Then identify what is attached at the hip to the x. And in this case, it's the 6x. So we've got to get rid of the minus 4. To get rid of the minus 4, we're adding 4. Notice it's the exact same steps as what we just did on this equation side. Only thing difference, here I carry down an equal sign. This time I'm going to carry down the less than symbol. Next, I'm going to get rid of that 6 by dividing by 6 on both sides. My 6's cancel. Make a fancy 1 there, so I'm left with 1x and a 5. And again, I'm just dropping down that inequality. So you can see that the steps are almost exactly, well, the steps are the same. The only thing that's different is this time I'm carrying down a less than symbol, and over here on the equations, I'm carrying down an equal sign. So something to remember is what we call the golden rule. Now, if I'm being really hateful and mean to you, if I'm your peer and I'm being really hateful and mean to you, you're going to flip out on me because I'm being rude and hateful. So something to remember is if you're multiply or divide both sides of that inequality, if when it's a negative number, it's like you're being negative to that inequality, and that inequality is going to flip out. So the sign will flip. So steps to solve graphing any steps to solve and graph inequalities. Sorry about that. Are all typed up here for you in case you get home and you're like, I really don't remember what Miss Montgomery said. So now it's all typed there for you. You're going to solve the inequality the same as you would an equation. Don't forget the golden rule. So if you're multiplying or dividing by a negative number, you're going to flip that inequality. I'll show you an example of that in a minute. Next, you're going to plot a point on the number line using either an open or a closed circle. Remember, an open circle is a less than or a greater than symbol. A closed circle has that or equal to property on it, so it's got to have that solid line. That's what's shading in that circle. Number 3 is to shade appropriately, left or right. Make sure to shade in the arrow to show that it keeps going on forever. So example number 4. I'm going to draw my line down my equal sign. And I'm going to get rid of the minus 4. In order to get rid of that minus 4, because the x is what we're trying to get rid of, and it's attached to the 3, I'm going to add 4. So when I add 4, please watch your signs, because this 3x just gets dropped down. I'm going to drop down my inequality of a greater than symbol because I did not multiply or divide by a negative. And then it's negative 16 plus 4 is negative 12. Next, I'm going to divide by 3. When I divide by 3, that gives me, this is a positive 1x. Negative 12 divided by 3 is negative 4. So at this step, you need to identify for yourself, did I multiply or divide by a negative? And it's this number right here that I just highlighted. If that number is negative, that's when you flip that inequality. That number was positive in this case, so you do not, you just keep dropping it down. Now, based upon this original inequality, or this bottom one, it doesn't matter, it's the same thing, it's going to give you an open circle because it does not have that equal to property. So I'm going to do an open circle on this number, negative 4. Now, this is saying x is greater than negative 4. So numbers bigger than negative 4 are all to the right. So we're shading that direction, and it's going to shade in my arrow. Now, what are some possible solutions to the inequalities? You can pick any number that's in the shaded region and beyond. So an example would be like a negative 3 or a negative 3.5. Both of those are in the shaded region. You could also say 0, 2, 5, 9, 15, 100. It doesn't matter as long as it's in that shaded region. All of these are possible solutions. Example number 5 will show you a different way or a different method, a different part of the inequalities. We got to get rid of those parentheses. In order to get rid of the parentheses, we're going to have to use the distributive property. So as I distribute, negative 3 times 7 is negative 21. Negative 3 times positive 3x is a negative 9x. And then I'm going to drop down my less than symbol and my negative 84. Now, my goal is to get this x by itself, and it is attached to the negative 9. So we are going to get rid of that negative 21. In order to get rid of the negative 21, I'm going to add 21 to both sides. That gives me everything in this orange box is negative 9x. And then this side over here is going to be negative 84 plus 21, and that is a negative 63. So I'm going to write negative 63 on that side. I did not multiply or divide by a negative, so I'm just going to drop down that inequality. The next step that I'm going to do is to get rid of that negative 9. This is negative 9 times x, so I'm going to divide by negative 9 on both sides. Negative 9 divided by negative 9 is a positive 1x. That's what I needed. And then negative 63 divided by negative 9 is a positive 7. Now, the number that I moved across the inequality sign by dividing, was that negative? If it is, you're going to flip the inequality. And in our case, it is. So I'm going to flip that inequality. Right now, it's a less than, so it's going to become a greater than symbol. As I graph this, it's going to be an open circle because there is no equal to part. And it's going to be on this number 7. So open circle on 7. And then I'm going to shade the direction that it's going to make a true statement. So what numbers can we plug in here for x is going to be greater than 7? Well, you can plug in 8, 9, 10. You could plug in 20. 20 is greater than 7. 59, 100, 1 million, somebody said earlier. So all of those are all examples of numbers bigger than 7. So to shade that, we're shading those numbers that make a true statement. Don't forget to shade in your arrow to show that it keeps going on forever and ever. Example number 6. This is an inequality with variables on both sides. The very first step to solve an inequality with variables on both sides is to move this negative 4a to the other side. So to do that, I'm going to add 4a to both sides. And now I'm left with 3 plus 9a is greater than, this is canceled, negative 6. I did not multiply or divide, so there's nothing to check to see if I need to flip my inequality. I just drop it down. Now I need to put my constants together. So in order to do that, I need to move this 3 to be within negative 6. So I'm going to subtract 3 from both sides. That gives me 9a. And this is negative 9. I'm going to drop down that inequality symbol because, again, I did not multiply or divide by a negative number. The last step here is to divide both sides by 9. So since I write too big, I'm going to bring it up over here. A and negative 1. Am I going to keep or flip? You should be looking at this part of your numbers. Was it negative? If it was, then you're going to flip it. But in this case, our number right here that we divided by was positive. So I'm going to keep that inequality symbol. Since that inequality symbol is a greater than symbol, it's going to be an open circle. And it's going to be an open circle on this number, which is negative 1. Now, the question to ask is what numbers are greater than negative 1? That could be solutions to this inequality. So what numbers can I plug in here to make a true statement? Well, I can plug in 0. 0 is greater than negative 1. That's true. 1 is greater than negative 1. So all of those are solutions. So that means I'm going to shade that direction to make those true statements, and I'm going to shade in that arrow. So other possible solutions besides 0 and 1, I could say 5, 10, 45, 100, so on and so forth. There's infinitely many there. Example number 7 is going to be the last easier part of this assignment before we get to the word problems. And example 7, I'm going to get rid of the parentheses first. In order to do that, I'm going to do negative 2 times 1 is negative 2. And then negative 2 times negative 6d is a positive 6d. Then I'm just going to drop down everything else that I did not mess with. So this is going to be a negative 6d is less than or equal to 6d plus 9. Next, I'm going to combine like terms that's on the left side of the equal sign since there are like terms here. Negative 6d plus 6d is 0. So those cancel out. Now I'm left with negative 2 is less than or equal to 6d plus 9. Now, I like my variables on the left side, but in this case, my variable is already getting close to being by itself on the right side. So I'm just going to leave it over here, and I'm going to move this 9 to the other side by subtracting 9. So that gives me negative 11 is less than or equal to 6d, because those canceled. Now, my goal is to get that d by itself, so I've got to get rid of the 6. In order to get rid of the 6, I'm going to divide by 6. 6 divided by 6 is 0. Or I'm sorry, it's not 0. It's 1. And then when you type in your calculator, negative 11 divided by 6, it's going to give you a decimal of negative 1.83 repeating. And that's going to keep repeating. And then since that number 6 was positive, I'm going to just drop down my inequality, and it's going to be a D. Now, when I go to graph this inequality, it's going to be a closed circle on negative 1.83. Now, I'm going to have to guess that one. It's going to be a closed circle right there. This is saying that number is less than or equal to D. So D has got to be bigger than that number. So the numbers bigger than that would be like 0, 1, 2, 3, so on and so forth. So I'm going to be shading this direction. Don't forget to shade in your arrow. Okay. All right. The next problem that I need you to do is word problems. We're going to be talking about at least. At least means greater than or equal to. More than is just means greater than. No more than is a less than or equal to symbol, and less than is just means less than. So I want you to write in greater than or equal to so you can see those symbols again on this page. And let's read this problem. A taxi service charges $1.75 flat fee in addition to 65 cents per mile. Katie has no more than $10 to spend on a ride. Define your variables. That's your let statement. So we're going to say X is equal to number of miles. To write the inequality to fit the problem, we are going to say the flat rate is $1.75. That does not change at all. So $1.75. And then in addition, which means adding, 65 cents, so 0.65 per mile. Mile is X. It says Katie has no more than $10 to spend. So no more than is actually a less than or equal to symbol. No more than is the same thing as saying it has to be smaller than 10 because I only have $10. So I'm going to go ahead and rewrite this inequality in order to solve it. $1.75 plus 65 cents times X is less than or equal to 10. Now, in order to solve this inequality, because it's got an inequality symbol, I'm going to subtract $1.75 on both sides. So when I do that, my $1.75s cancel. And then I have $10 minus $1.75, and that's equal to $8.25. So on this right-hand side, I've got $8.25. I'm going to drop down my inequality symbol because I did not multiply or divide by a negative number. And then I've got 0.65 and an X. To get the X by itself, I'm going to have to divide by 0.65 on both sides. This side gives me an X. And then the other side, if I divide it exactly as I see it, it's going to look like this: 8.25 divided by 0.65. And it gives me an answer. Oh, you can't see that. There you go. It gives me an answer of $12. Since I'm talking about money, it's going to be $12.69. We would round to 2 decimal places there. Now, since I divided by a positive number, I just dropped down that inequality. So write a sentence to answer the question, how many miles can Katie drive? I'm going to just say Katie can go no more than 12.69 miles. And how I got that was x is less than or equal to 12.69. All right, looking at this next equation or next problem. Bill weighs 240 pounds and is losing 2 pounds each month. Phil weighs 290 pounds and is losing 4 pounds each month. How many months, which is M, will it take for Phil to weigh less than Bill? Less than looks like this. It's saying to define your variables. You should recognize this problem because we did it with an equal sign earlier in the unit. But we're going to say M is equal to the number of months. It tells us that right here. How many months, which is M. Write the inequality. Remember, it's going to be Bill has to be less than, how many months will it take for Phil? Let's do it right now. Phil to be less than Bill. So let's talk about it. Bill weighs 240 pounds. So it's going to go on this side, 240 pounds, and is losing, that means minus 2 pounds each month. So 2 times M. Phil, on the other hand, weighs 290 pounds, and he's losing 4 pounds each month. So now we've got the inequality we need to go ahead and solve. So in order to solve this inequality, I'm going to move this negative 2M to the other side by adding 2M. This side cancels. I'm now left with 290 minus 2M is less than 240. Now I need to move my my constant term to the other side. So I'm going to subtract 290 on both sides. This cancels. I'm left with this negative 2M. I'm going to drop down my inequality because I did not multiply or dividing. I'm subtracting. And this would be negative 50. Last but not least, I'm going to divide both sides by negative 2. Negative 2 divided by negative 2 is a positive 1M, and this is a positive 25. Now, since this number right here that I divided by was negative, I'm flipping the inequality. So now that inequality is going to become a greater than symbol. So to answer the question in the scenario, it said, how many months, M, will it take for Phil to weigh less than Bill? I'm going to say it will take more than 25 months for Phil to weigh less than Bill. So that's how you solve these word problems that are inequalities. And today, now you're going to get an assignment to go along with this lesson. I hope you all have a great day. Be safe, make good choices.